All right, everybody. I want to talk about basically heat transformations, like how heat transferred um, to different substances. Now, when we talked about this earlier in the year, heat is just kind of another way of talking about how energy is transferred from one object to the next. And we talked about how it always goes from a hotter object to a colder object. It never goes from a cold object into a hotter object. It always does that. Experiments show it all over the place. If it didn't, then if you put an ice cube into a cup of hot coffee, the ice cube would grow if it went the other way. The heat goes into the ice cube. It goes from the hot liquid into the ice cube and melts and slows and speeds the movement up of those particles in the cube that they become liquid. They're moving too quick to be in a solid form. And eventually that heat dissipates and they cool down and they slow down over time. And if you keep cooling them down and they remove heat, the heat leaves that to go kind of go into a colder object or colder things, then it leaves less heat behind as the heat is moving out. It leaves less heat behind and it cools it off. So when you put your head in the freezer, it isn't that the cold's going into you, it's pulling the heat out of you. The heat's leaving you to warm up the freezer, is the way it goes. And it all works because particles are moving fast. And the faster they move, the hotter that particle is. And if it hits a colder particle, it's going to make that particle go faster, but this particle is now going slower because of it. It's cooled down. The heat left this particle to the other particle. That's kind of how it works. So, the three types of heat transfer are through conduction, which is touching things. When you have a hot thing where all the molecules are moving really fast and you press it on something where they're not moving as fast, it's going to transfer that heat. And that heat's conducted and it'll flow through it. So even if you have like a piece of metal and you put your hand on it and you can feel your hand getting cold from it and you pick it up, after a while, the rest of the metal plate, the coldness will kind of like filter out. The heat will spread out through the whole plate and it'll come to a uniform temperature. You can put your hand on it again and it'll feel cool again. Those types of things will happen. So that's conduction. It's when particles are actually touching each other. The second one is radiation. This is one that's a little less intuitive, but we can view it as sunlight. Radiation comes from the sun. Okay, it's an electromagnetic wave that comes through. It's just like a radio wave, only we feel it as heat. These light waves come in and they're absorbed by the atoms on the ground, and when they absorb those energies, they vibrate a little bit faster. They warm up. So that's kind of how heat is transferred through empty space, through radiation. And then the last one, and probably the one that we want to focus on the most, is convection. That's what happens in the mantle. The heated fluid becomes less dense because the particles move faster, they need more space, so they become less dense, they rise, more dense, cooler particles fall, take their place. Happen in the mantle, okay, in the asthenosphere, where you have the hotter stuff rises, hits the lithosphere, the crust, and pulls it apart, pushes the plates apart, and you have seafloor spreading as the stuff comes up onto the ocean floor. Other places where it's moving, where it's descending, you see plates are being pulled down, and you have subduction, and then you get your volcanoes and all that stuff. Same thing happens in the atmosphere. So all weather that we have on Earth comes from the sun. It is the source of all our weather when we get down to it. Our atmosphere, we have our atmosphere. Sun through radiation heats the surface of the earth and heats different layers of, like the stratosphere or the ozone layer absorbs some of that heat. But basically, the surface is warmed by the sun. Okay, so that's the first step. The second step is that warmth on the surface, the air that's that's laying right on top of it gets warmed by that surface through conduction. The second form of heat transfer. So first is radiation from the sun warms the surface of the planet. The air right on top of that gets warmed from it, from sitting right on it, becomes less dense and starts to rise. Colder air comes down on top of it, gets warmed again, rise. This causes a convection current. The conduction of heat, radiation heats the ground then conducts that heat to the air. That warmer air will rise, cooler air will fall. That's a convection current. That's what causes virtually all winds on Earth. Okay? As air is rising, we found out what? Rising air, is that high pressure or low pressure? It's low pressure. That rising air is low pressure. So if there's rising air in an area, if it's a large area, other areas that are high pressure, the air is going to swirl in and move in from those areas of high pressure. So the sun causes winds. Okay? So as the air rises, what does it do? We know from when we talked about the layers of the atmosphere in the troposphere, as you get higher, like as you climb a mountain, it gets colder. As that air rises, it gets colder. That rising air, low pressure air, okay, if it has any humidity in it, any type of water vapor, as it rises, it cools and forms clouds. So low pressure systems form clouds, and they're usually associated with rain and kind of like miserable weather like that. So that's kind of where we're going with this. Now, high pressure is falling air. It's pushing down. It's high pressure. Now, if there's water vapor in that air or there's clouds, as that air is pushing down, that cloud is warmed up and the clouds evaporate. Now you have like kind of like you won't have a cloud anymore. As it's falling, that falling air, it's usually kind of like warming air. As it gets closer to the ground, it's not as cold, so it's not going to form clouds. You're going to have clear skies, and it's not going to rain as much. That's pretty much weather, okay? The sun also evaporates water from surfaces like the oceans and lakes and things like that, puts humidity into the air, forms clouds as the air is rising, low pressure. Winds blow those clouds to different areas and it rains on those different areas. That's how weather works. And that's kind of like the short, kind of like Cliff Notes details on how weather works. So we have our heat transfer. Always goes from a hotter object to a cooler object. Okay? Ground is warmed from radiation from the sun, conducts that heat to the cooler air. That air is warmed up, it rises. As it rises, if there's humidity in it, it can condense into clouds, low pressure. You end up with cloudy, rainy weather. Cooler air comes in from higher pressure areas, and that again is warmed again, and that will rise, and it goes over and over. So we're setting up kind of like what we're going to look at in the next couple days with land breezes, sea breezes, and then global winds. Global winds get a little bit more complicated when we start talking about that. But the land breeze and sea breeze should be pretty easy, and we'll do that tomorrow. See you then.